This is lesson 10.3, chords. A chord is a segment whose endpoints are on a circle. We're going to start off with why the two chords RS and UT are congruent. So on the left we have our chords, and we drew radii from Q, the center of the circle, to each endpoint to make two triangles. So looking at the two central angles, we can see that they're congruent because they are vertical angles. And all the radii that we see in the center of the circle, QS, QR, QT, QU, are all congruent because the radius does not change length. So now we see that we have a side, angle, side, so they are congruent by SAS. And now we can look at the corresponding parts of the triangle, and because S and T are in the same place and R and U are in the same place, they are congruent by SAS. We're going to move on to theorem 10.3, and it says if two chords in a circle are congruent, then their central angle is congruent. So that's saying that if MN and PQ, these two angles on the side, are congruent, then their central angles in the middle are also congruent. And this also works with their converse if we just flip the statement. The next theorem we're going to talk about is 10.4. If two arcs in a circle are congruent, then their chords are congruent. So this one's saying that if the angle or the arc between MN on the left and PQ are congruent, then the arc length, or the chord length, is also going to be congruent. And this works with the converse like above as well. Make sure that you are able to use the difference between the arc and the line segment symbol. They do look very similar, but the arc, of course, has a curve to represent the curvature in the circle. Our last theorem is 10.5. If chords are equidistant from the center, then they are congruent. So that's saying that FS and SE are congruent. As you can see, they're also perpendicular bisectors. Then the line segments or chords A, B, and DC are also congruent. And again, this also works in the converse if we flip the statement. So that's like saying if F and E are the same distance, then this longer line segment AB or chord and DC are also congruent, and these work both ways. So in this question, we are given that the arcs RS and UT are congruent, and that we are looking for UT, the length of it. So we do know that using theorem 10.3 that RS and UT are congruent because if they have the same arc length, or measure of arc, then they do have the same chord length as well. Another thing that we're given is both the distance from Q to that midpoint of UT, and we are given the radius of 5. So if we draw a radius from Q to T, we know that that's also going to be 5, and we are able to find the distance from the midpoint to T using Pythagorean theorem. So we were able to plug in x squared plus 4 squared equals 5 squared. We can go ahead and start by simplifying and squaring everything. And to get the x by itself, we start by subtracting 16 on both sides. And we get x squared equals 9, and then square root both sides to get x equals 3. So since the distance from that middle point to T is 3, and it is the midpoint, we are going to know that this side is also 3, so the distance from U to T is equal to 3 units. And that's the end of this video for 10.3.